right. Practice example 15.6a and b concern Le Chatelier's principle, the application of it. And so in A, we are given a reaction 2CO plus O2 goes to 2CO2, all in the gas phase, balanced. And the question says that if you add oxygen gas to this constant volume equilibrium mixture, how will the system react in order to reestablish its equilibrium? Well, it's all gas phase, and I'm adding oxygen gas. Oxygen is one of the reactants, and therefore the system will react by consuming it, and the equilibrium position therefore will shift to the right, because as that extra oxygen is consumed, some CO2 will actually be produced. So that's how the system should react. If we look at the second one, B, we have calcium carbonate solid is heated to give calcium oxide solid and carbon dioxide gas. The system has reached equilibrium and is therefore at a constant temperature, and it's in a constant volume container. That's what they tell us. So we can see that the Kp for this reaction is just simply equal to the pressure of carbon dioxide. Or similarly, the Kc would be equal to the concentration of CO2. And so they're asking us, what's the effect on the equilibrium position by adding some CaO? There was some confusion about this question because when we did this in lecture, we spoke generally, and those slides are on Blackboard in the lecture folder, but we spoke generally about adding a reactant or a product to a reaction mixture and how the system would react. So if we spoke too generally about this system here, we would say, well, we're adding a product, so the reaction should consume it, and therefore the position should shift to the left. That's not the case, however, because CaO is a solid, and the solid is not in the equilibrium expression. So it's more than just adding reactant. It has to be adding a reactant or a product that's actually in the K expression. And so there's really no effect on the equilibrium position here, because adding this solid has no effect because it's not part of the K expression. So that one could be a bit tricky. But if we add some carbon dioxide, well, we're adding a product gas, and what's going to happen is that this upsets the equilibrium, and so the reaction should respond by taking care of that, by consuming it, and therefore some more calcium carbonate should be produced. But that's because the position is shifting to the left to take care of the added CO2. And it has an effect because CO2 is in the K expression. And then finally in C, we are adding CaCO3 solid. And for the same reason that we said in A that adding a solid has no effect on the equilibrium position, that is also the case here because K is just made up of PCO2. And so adding CaCO3 does not, to this system at equilibrium, does not affect its equilibrium position. So that's it for practice example 15.6.